Hello guys, welcome to today's video. Today we are going to start with the last chapter in our syllabus, that is organic chemistry, and that is indeed a huge chapter. So let us begin the video. Organic chemistry, what do you understand by this term? Organic, something that is obtained from living organisms, right? So organic chemistry was initially defined as the branch of chemistry or the compounds branch of chemistry definitely that deals with the compounds that are generally obtained from living organisms. Generally it is the plants, generally I'm talking about, okay? But modern definition will not say this. Why? Because currently maximum, or rather I will say almost all the organic compounds are synthesized in the laboratory. So we cannot define organic chemistry as that. So we have proved a new definition for organic chemistry that states that organic chemistry is the study of hydrocarbons and its derivatives. Clear? So we are mainly going to deal, not mainly, when we are going to deal with hydrocarbons mostly, okay, in the organic chemistry that we have at least in our syllabus, okay. So let us begin the first part, that is the main part. What is the main part of organic? Carbon. So carbon forms the maximum or the most part of the organic chemistry. Carbon has to be there. Without carbon, organic chemistry is not possible. So carbon is the main factor in organic chemistry, right? Carbon. This compound, this element will form compounds in organic chemistry, okay. Now tell me about carbon. Carbon has got the electronic configuration of 2, 4. So it has got 4 electrons in its outermost shell. So it is not going to lose the 4 electron, neither it will gain the 4 electron. What will it do with the 4 electron? It will share the 4 electron, right? So it can share, maximum it can share is 4. So it can have 4 single bonds. First understand this. It can share maximum of 4 electrons. So it can have 4 single bonds. Okay, no double bond, triple bond right now, only single bond. So it can have 4 single bonds. Clear? This is called tetravalency. Clear? What is tetravalency? The ability of carbon to form 4 single covalent bond is tetravalency of carbon atom. Clear? So unique property of carbon, number 1, it is tetravalency of carbon atom. Second property is catenation. In computer you have done string concatenation, that is what you used to use is you have to merge two strings, correct? So here also catenation means linking of carbons, clear? Self linkage, like this. 2 it can continue, it will not end, it will continue, clear? This will continue. So this is the property of self linkage. So the word self linkage must be mentioned in the definition when you are writing the definition of catenation. The word self linkage is very important. So it will self link with carbon to form either branched chain or straight chain, as like this. Branched chain, I mean to say, is it can be like this, a branched chain. Clear? I am not satisfying the valencies right now, clear? Because I am not going to throw you in any confusion. So it can form a branch chain like this. This is just a skeletal equation or a carbon equation, okay? It's a skeletal equation, please, okay? This carbon root equation, okay? Self linkage, branch chain, this one, straight chain, this one, or it can form cyclic compounds. How does a cyclic compound look like? Cyclic compound will look like carbon, carbon, carbon. Clear? It can form cyclic compounds. Now a cyclic compound will always look like this? No, can look like different types. Clear? So it can form 3 types as of now, that is cyclic, branched and straight chain compounds. Clear? Okay, straight chain, branched and drawn, this is cyclic. Okay, so the property of self linkage of carbon atom to form branched straight chain cyclic compounds is catenation. Understood? Catenation done. Third unique property is isomerism. That is coming later on. Clear? I have just told the term isomerism. That will be discussed later in details in the last part of the video. Maybe in this video or the next video. In the last part, not now. Okay. Understood this much? Now we will be moving on to the most important thing. What is that? Single, double, triple bond. Single, double, triple bond. Okay. Here I have discussed about single bonds. Now, what if there is a double bond? First, you have to understand the satisfaction of bonds. Suppose I place two carbons. Okay. So how many hands are still empty? One hand, two hand, three hand, four hand complete. You have to check for four hands being complete. Four hands complete. How many left for here? Three hands, one hand, two hand, three hand, four hands complete. So both of them are satisfied. Now here in the free hands we will put hydrogen. Clear? Free hands we will put hydrogen. Clear? So this is what type of single bond. Clear? All single bonds are there. Double bond is not present. So all these are single bonds. Clear? Condensed formula I am just writing. I will be coming to condensed formula later on. So this will become the condensed formula. Double bond is not there. So this will become CH3, CH3. Okay. Clear? No need to worry about this. Coming to it later on. Okay. So this will be single bond. Now what modification will take place if I write C double bond C? I have written C double bond C. Previously it was C single bond C. Clear? And if you have noticed that we have got one hydrogen here, here, here and three here. So total formula previously was C2H6. Right? C2H6 was the previous formula. You can calculate the formula by counting the number of carbon atoms and hydrogens. Now here two hands filled up already. So can we pair like this? And how many hands? 5 hands. Do we need 5 hands? No. So which hand we can remove? Let us remove this hand. Then remaining of the hand. Clear? Now here also two carbon done. So 1, 2, 4. So hydrogen over here, hydrogen over here, hydrogen over here, hydrogen over here. What does the formula become? C2H4. So condensed formula is CH. Clear? Okay. No need to worry about this again. Now what modification will take place if I write instead of this C triple bond C? Then how many hands are free? One hand is free. So only one hand. How many hands are free? One hand. Instead of this put hydrogen. What will the formula now become? Clear? Why am I writing the formula? Because the next part is the formula part. Okay. Clear? Understood? Okay. Now wherever you find that there is single bond between carbons. What did I say? Single bond between carbons. Here C2H6. Two carbon. Here hydrogen. Here hydrogen. Here hydrogen. Here hydrogen. Here hydrogen. Here hydrogen. This was a structure. Correct? This was a structure. So here all single bonds are there. So whenever all single bonds will be there, the name will be alkane. What is the name? Alkane. Focus on the word ane because this will be used in the nomenclature. Clear? So it will be alkane. What is the word? Alkane. A-N-E. Clear? Alkane. Where all single bonds are there. Do not focus on this single bonds. Focus on this two single bonds. Single bonds between carbon atom we are bothered with, not any other. Clear? Okay. So this is belonging to which group? Alkane group. Clear? Belonging to which group? Alkane. Okay. Now this structure done. Alkane understood. So alkane means carbon carbon single bond. Clear? Carbon carbon single bond. Let's not write this. Let us write alkane now. Alkane, ANE I am writing, okay. ANE means carbon carbon single bond. Okay. Carbon carbon single bond. Now next one was C2H4 if you remember. So C2H4 was two carbon, double bond in between, one hydrogen over here, not right here, one hydrogen over here, one hydrogen over here, one here, right? Correct. This was C2H4. So now, is there a double bond? Yes, there is a double bond in between. There is a double bond in between this one. So the name will now no more be alkane but alkene. What changes happen? A became E. Correct? So it is alkene. So E and E will be having C double bond C. Clear? C double bond C. That is alkene. Clear? Whenever you see between carbons there is a double bond, do not check anything else. Thus has to be alkene. Yes, if other things are present, then you have to check it, and that is nomenclature. We have not yet come to nomenclature, so need not worry about that. But whenever you see double bond present in between carbon atoms, has to be an alkene. Now, double bond might be present somewhere else and not in carbon atom, as in case of functional group that I have not yet come to. You will not consider that as alkene. Please, you have to understand. Carbon double bond has to be there, not any other double bond. Okay, carbon double bond. Okay, now the last one was C2H2, if you remember. Last one was C2H2. So C2H2 had a triple bond in between, correct? So like this, there is triple bond. So whenever there is a triple bond, the word alkyne comes into play. Which word? Alkyne. So here you have to write ine, that is C triple bond C. Clear? Triple bond C. So whenever there will be a triple bond between the carbon atoms, there has to be alkyne coming into play. Which word? Alkyne. Least bordered with alk. We are bordered with ine. Ine, in and n. That is why I have written the last portions only. Alkane, alkyne, alkene. Clear? Alkane, alkyne, alkene. Understood? Very important. Ine, single bond, in, double bond, ine, triple bond. Clear with this? Understood? Clear it. Okay? Now, we will be moving on to hydrocarbon classification. Okay? We will be moving on to hydrocarbon classification. Okay. Basic classification of hydrocarbon is done on basis of hydrocarbon at the top divided. First step division. Lot of division, subdivisions are there. First step division is hydrocarbon. First, do you know what is a hydrocarbon? What do you know what is a hydrocarbon? Hydrocarbons are compounds made up of only carbon and hydrogen. Clear? Only carbon and hydrogen, if their compound is made up of, it is a hydrocarbon. Clear? Carbon and hydrogen. Okay. Now first step division is that this is divided into aliphatic. First division is divided into aliphatic, and this part is cyclic. What is the first step division? Aliphatic, cyclic. Clear? Cyclic is not there in our syllabus. More or less not there in our syllabus. There in class 11. Clear? Cyclic. This is aliphatic. Aliphatic is again subdivided into two further. That is, I am writing in short. Okay? Do not write short. Saturated and unsaturated. Saturated, unsaturated. Clear? Saturated divided into alkanes. Only one is there. Alkane. It was discussed already before. Alkane means single bond. Clear? Another name of alkane is paraffins. Okay? Another name of alkane is paraffins. Clear? Now this unsaturated has been divided into the remaining two, alkene, that is called olefins, and alkynes. Clear? And alkynes. Clear? So we are bordered with this part only. This part is least bordered, but still we have to just know the classification. Clear? Understood? So aliphatic is divided into saturated, unsaturated. Saturated means alkane, unsaturated is alkene and alkyne. Clear? Now cyclic. Cyclic has been divided into two parts. One is alicyclic, and one is aromatic. Okay. one is alicyclic, one is aromatic. Cyclic has been divided into these two. Clear? One is alicyclic, one is aromatic. So this is the basic flow chart that you need to remember. Classification. Repeating again. Hydrocarbon on the top divided into aliphatic, cyclic. Aliphatic divided into saturated, unsaturated. Saturated means alkane, unsaturated is alkene and alkyne. Cyclic has been divided into alicyclic and aromatic. Clear? Done? Okay. Now we'll be going on to the respective compounds. Since this two parts is very small part is covered in your syllabus in class 10. So I will be discussing cyclic first, then I will be going to aliphatic because it's all aliphatic only. Clear? So let's discuss cyclic first, then I will go to aliphatic. Cyclic is very less in number in your syllabus, I mean. Okay. Cyclic. So as I've already discussed in the definition of catenation, that carbon can form cyclic compounds as well into self linkage. So cyclic means closed structure. Cyclic means closed structure. That can be a triangle, that can be a square, that can be a pentagon, that can be a hexagon. Anything it can be called, any shape, but do not say it as a circle, please. Okay. So it can be this type of shapes. Now how is it formed? Generally, when you go for ISC or higher exams, you will be like given this structure and will be told to name this structure. Might be. Until you do, you will be saying what pentagon is given suddenly. But there is some rule to this that we are not going to discuss right now. No need to hurt your brains. Okay. Cyclic. So first step is subdivision was that it was alicyclic, if you remember. Alicyclic, correct? Cyclic divided into alicyclic and aromatic. So alicyclic means closed structure. Closed structure. Now use your brain and say me how many carbon will be required at least. At least how many? Can one carbon fulfill? Definitely no. I am drawing one carbon. Does it make any closed structure? No. I am drawing two carbon. Does it make a closed structure? Straight chain compound, no closed structure. Now if I draw a third carbon, now does it make a closed chain? Yes. So what is the minimum number of carbon? 3. Clear? 3 minimum carbons required for this alicyclic compounds. Clear? That is a closed chain compound, cyclic compounds. Okay. This is alicyclic. 3 minimum carbon required for formation of a closed structure. Clear? This can be one. Now if I give a like this, actually it is a square. If you can see properly, it is a square. This is a triangle. So it is a triangle if it is asked to name it like that. Clear? Okay. Now this I am drawing carbon skeletal equation. Okay. I am not giving the hydrogen. That does not mean that hydrogen is not present or it is present, very much present. It is actually like this. Clear? Actually like this. But I am not giving the hydrogen because I am drawing the carbon skeletal structure. Okay. So this is the alicyclic compounds. Example. One example I will give. That's cyclohexane. No, not skip cyclohexane. That's cyclobutane. Clear? Butane. Now we will say what is butane. Butane. What is but? Coming to but. Okay. Just a little bit. Hold on for some time. I am coming to but. What is but? How does it come? Just staying after 1 minute. Okay. Just hold on for some time. Cyclobutane. Clear? Structure is carbon, 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 carbon. Clear? Cyclobutane. Clear? This is cyclobutane. Understood? Structure is this. No need to worry about the structure right now. No need to worry about the structure right now. This is cyclobutane. Clear? What is what I am telling. Okay. This is done. Okay. Next, another classification under cyclic was aromatic. If you remember, aromatic was the second classification. So let's write aromatic. Aroma. this word. What does aroma mean? Some fragrance, some smell, some good smell is coming as aroma, right? So they will have some aroma. Clear, simple. They will have some aroma. That is, they will have some pleasant smell. So if they are having some pleasant smell, we will be keeping them under aromatic compounds. Example, in your what to sell Almiraj, you know, you keep that naphthalene balls. They are having a very good smell. If you have ever kept it, then you will have got the smell. So that smell is due to this aromatic compound, right? Because it is an aromatic compound, right? It is an aromatic compound. Naphthalene is an aromatic compound. Clear? Structure I am drawing, but no need to worry about the structure. Clear? Structure is like somewhat like this. Clear? Structure is somewhat like this. Clear? This slide I am leave it. No need to draw the figure. There is draw like this only. Clear? This is the structure of a naphthalene. Clear? This is the structure of a naphthalene. Okay. One double bond is here. One double bond is here. One double bond is here. One double bond here. One double bond here. One double bond here. This is the structure of naphthalene. Naphthalene. Clear? Spelling of naphthalene. Be careful with the spelling. Okay. Spelling of naphthalene. So this is how a naphthalene looks like, and it is an aromatic compound. So whenever there is an aromatic compound, benzene ring has to be there in it. This is benzene. This is benzene. Two benzene combined together, naphthalene forms. Clear? So this is benzene ring has to be there. At least one benzene ring. This is two benzene ring. One benzene ring has to be there. At least one benzene. Clear? At least one benzene has to be there in case of aromatic. Clear? At least one benzene ring has to be there in case of aromatic compounds. Benzene structure is clear? Benzene structure is this. If you want to make it a little bit flat, then you can do like this also. Fatty benzene. Clear? It's also benzene, all benzene, same benzene. Clear? Now another compound, another two compounds can be formed from benzene. You add over here OH, this benzene transforms into phenol. Instead of this OH, if you write CH3, this becomes toluene. Clear? These are some examples of aromatic compounds. No need to worry, just I am saying the example. Okay. So instead of this benzene here, instead of hydrogen, you add CH3 group, toluene, you add OH group, phenol. Two benzene combined together is naphthalene. Okay. Aromatic compound chapter closed. Now forget about aromatic compounds. Now we are going to get into aliphatic, but before that let me tell you about but that I said. No, what is but? So basically we name based on the Latin Greek words. Clear? Based on Greek words we name. Clear? So if there is one carbon present, that is carbon 1, then we say it as meth. Clear? We begin it with meth. Clear? Now it is E9, whatever it is, we have to place it as suffix. Clear? If there is 2 carbon, we write it as eth. If there is 3 carbon, we write it as prop. If there is C4, we write it as but. That is the reason I wrote but over there, cyclobutane, and 4 carbon were there. Clear? C5 is pent. Clear? Then C6 is hex. C7 is hept. C8 is oct. C9 is non. And C10 is dec. As of now, till C10 is okay. C30 is also there. Lot of things are there. Till C10 for now it will work. So what is C1? Meth. C2? Eth. C3? Prop. But, pent, hex, hept, oct, non, dec. Clear? Understood? So this you have to memorize. This you have to keep in mind. First is meth. Second is eth. Third is prop. Fourth is but. Fifth is pent. Sixth is hex. Seventh is hept. Eighth is oct. 9th is non, and 10th is dec. Clear? This name, if you can remember this part, then it will become easier for you to write the nomenclature names. Okay? Clear? Now can I move on to aliphatic? Okay. Aliphatic. Aliphatic compounds. Division was saturated and unsaturated. So I am directly getting into saturated compounds. Saturated compounds. Saturated means it has already filled up its tummy. Clear? Tummy filled up. Nothing more it can eat. C double single bond C, single bond C. Tummy filled up. Nothing it can accommodate inside it. Saturated compound. Clear? Tummy filled up. Nothing it can accommodate. Saturated compound. Okay? Understood? Is a saturated compound. That means it's all single bonds present. All single bonds present has to be saturated compound. That is alkane. Clear? That is an alkane. Okay? Next, unsaturated. Unsaturated. That means my tummy is not yet filled. C double bond C. My tummy is not yet filled. C triple bond C. These two people have not yet filled their tummies, so they can eat up more until this triple bond will convert to single bond. Till then they will keep on eating. Clear? Now in what sense they will eat? They will eat in the form of reactions. Clear? You eat food, they will eat reactions. Actually they will not eat reaction, they will do reactions by eating some other compound. Obviously. Okay. Okay. Now there lies the difference. What is the difference? In case of saturated compounds, only single bonds are there. In case of unsaturated compounds, triple bond is there, double bond is there. Clear or not clear? Clear? Next, all the four valencies of carbon for first one, that is alkane, that is the saturated, is satisfied. Clear? All the four valencies of each carbon is satisfied by forming six covalent bond with single covalent bond with carbon and hydrogen. In unsaturated, the valencies of at least two carbon atoms are not fully satisfied by the hydrogen atoms. Of at least two carbon atoms will be there whose your tetravalency will not be satisfied by the hydrogen atom. So it will eat more. Clear? Understood? The last difference is the important thing. Substitution reaction and addition reaction. Substitution reaction and addition reaction. Now as I have already told, if you can remember it like that, my tummy is full. Alkane will say my tummy is full, I cannot eat anything more, but I can substitute what I have eaten. Okay, I cannot eat anything more, but I can just substitute what I have eaten. Clear? That can be done by the alkane. Example, very example. Methane. Methane is the first member of alkane group. Clear? Let me go to alkane group and discuss about every member. Next part is only alkane. Clear? Clear? So methane says my tummy is full, I cannot eat anything more, but I can substitute. Cl2 has been added to this person. What will this methane do? Methane will say, okay, let me replace one of my hydrogen with this person. Let me replace one of my hydrogen with this person. Clear? So this is substitution reaction. Product form will be CH3Cl plus HCl. So what happened? One hydrogen of this got replaced by this one hydrogen. So one hydrogen was replaced, one hydrogen shortened, this went over here to combine to form HCl. The product is this person. Right? Product is this person. Correct? CH2Cl is the product. Understood? Understood? Methyl chloride obviously. Methyl chloride is the product. Clear? Methyl chloride and hydrogen chloride is the product. So this person says, take one of my hydrogen and let chlorine combine with me. So substituted to form this person with HCl. So this is called substitution reaction. Who undergoes? Saturated compounds. Now unsaturated compounds, they will say I can eat more. I can eat more. Unsaturated compounds, they will say I can eat more. Let me eat more. So what will it do? Suppose I take C2H4. Okay. What is this? Naming I have not yet come, but this is ethene. Clear? This is ethene, the first member of alkene group. Clear? Ethene, the first member of alkene group. Now with this, if I add Br2, this person will say, give me more, I will eat it. It will not displace, it will not give one of the hydrogen to them to form HBr. If you write C2H3Br plus HBr, this if you write, this will be a big cross. Why? Because unsaturated hydrocarbons, as I already said, their tummy is not filled. Why will they substitute? They will eat more, right? So product form will not be this. What will be the product form? They will eat up that also. So product form will be C2H4Br2. So this reaction is called addition reaction. Addition reaction. More added. My tummy is more filled. So it will add up this with this. Clear? This is C2H4Br2. Understood? Clear? So this is one of the vital point of difference between unsaturated and saturated compounds. Okay, next we are coming to alkene group. Alkene. Alkene. Sorry, not alkene. First alkane. Alkane. You have to remember one general formula of a series. Whatever it be a series, there has to be a common general formula that will be applicable for all the members of that series. So for alkane, that general formula applies is CnH2n plus 2. What is the formula? CnH2n plus 2. N has to be a whole, N has to be a natural number. N has to be a natural number. If you give n as -1, not possible. If you give n as 1 point something, not possible. So it has to be a whole natural number. Okay, 0 is also not possible. So you have written natural number. Clear? So n is a natural number. So if I give C as 1, what will be the compound form? CH4, 2 into 2 plus 4, that is 2 into 1 plus 2, that is 4. So CH4, that is named as ANE, correct? ANE will go as suffix. Who is the prefix? One carbon means meth, correct? And suffix is N, so the name becomes methane. So the first member of this alkane group is methane. Clear? Generally the question comes first member or fifth member or fourth member, that you have to calculate by putting the value of carbon in this, then you will get a value of hydrogen. Clear? Okay, suppose I ask you the sixth member of this, what will you write? C6H14, name will be, for 6 it is hex, and this will remain in, so it's hexane. Clear? Hexane. Understood? So like this, from 1 to 10 you have to remember, right? Remember in the form that is practice. Clear? No one has told to remember you the names. Remember, meet, eat, that part. Then only you can make the names on spot. No problem will be there. But you have to remember the Greek words. Clear? If you can remember that, this name need not be memorized. You can get this formula by applying this formula. You will get this formula which you can write in the examination hall there itself. No problem with that. Clear? Next, alkene. Second, alkene. 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 Now, focus on the word ene. Clear? General formula is CnH2n. What is the formula? CnH2n. Previously it was 2n plus 2. If you have remembered, it was 2n plus 2. This formula is H2n. Only H2n. No change. Clear? That plus 2 has been not there, written in the formula. Clear? So you have to utilize this formula now to get this member, this group members. Clear? So let us write carbon 1. Okay, carbon 1. Ready? What will the name? CH2. Okay. Structure CHH. Where did the rest go? No, nothing is there. Is the valency complete? Tetravalency complete? No. It is not complete. How can the compound be formed? So first member is not this person of this group, alkene. Clear? Alkene group, first member is not CH2. Often you all write, this is nothing. Nothing is this. It is just a difference of two successive members of homologous series. We will come into it later on. Okay? Understanding? So who is the first member? C1 is not possible. So who is the first member? C2. If we write, then it is C2H2N plus 2N. So it's C2H4. Name is ethene. Correct? 2 carbon is ethene. So this is ethene. Structure C single bonded with C, double bonded with C. Right? Hydrogen, 1, 2. 1, 2, 3, 4, done. 1, 2, 1, 2, 3, 4, done. So hydrogen, hydrogen. Clear? Structure is like this. Bond line structure. If you are drawing electron dot structure, remove this bond, put 2 electron, done. Okay? I am not drawing electron dot structure, I am drawing a bond line structure. If you want to draw electron dot structure, instead of this, put a cross over here put a dot, here put a cross dot, here put 2 dot, 2 dot, 2 dot, 2 dot, 2 dot, like this, cross dot, cross dot. Done? Sorted? Electron dot structure done. Clear? Understood? So the first member of this group, alkene, is not methene, it's ethene. Okay. Now, if I ask the sixth member of this group, who is it? This is the question that we have to face. See, since methene is not the first member, then if sixth member is asked, seventh one will be the answer. Okay, always remember this. For alkene and alkyne, if sixth member is asked, then the next member is the answer. Clear? If fifth member is asked, then sixth member is the answer. If seventh member is asked, then eighth member is the answer. So here I have asked for sixth member. So answer will be seventh member. So answer will be C7H14. That is heptene. Clear? This is the sixth member of alkene group. Why? Because we are not starting with methene. So here 2, 3, 4, 5, 6, 7, that is the sixth member. So understood? For alkene, whenever it is asked, whatever it be asked, like if it is asked third member, then we will let C equals to 4. Then if it is asked fifth member, C equal to 6 you will write. If it is asked sixth member, C equal to 7, that I have taken. Clear? This is for alkene and alkynes only. For alkene, if you end up writing this wrong. Clear? Understood? Now, if I change this to alkyne, then focus on the word alkyne. Okay, alkyne. So focus on the word ine. Clear? So here the formula will change to 2n minus 2. Clear? 2n minus 2. Clear? Now, here also if I write 1, check why it is not coming up to check. So if I write 1, then it will become C1, that is C actually, H2 into 1 minus 2, H0. Can a compound called CH0 exist? No. So in that case, this compound will also not exist. So what will happen? C has to be equal to 2, so the compound will become C2H2 and that name is ethine. Clear? Ethine. Similarly, if I write C6, then it will not be the sixth element, it will be the fifth member of the group. I have written C equal to 6. What member? Fifth member. Fifth member is C equal to 6. Clear? So what is the name? C6H12 minus 2. So C6H10. Clear? C12 minus 2 is 10. So C6H10. What is the name? Hexyne. Clear? Hexyne. Understood? So this was all about alkyne group. Clear? Understood everyone? Next, we are moving on to the next topic. Homologous series. What is a series? A series means something which has got a uniform decision, uniform difference between them, and all it will form a series. Something is common in between them. Like if I write 1, 3, 5, 7, 9, 11. What is common? They all are odd numbers. They all are odd numbers. Difference 2. difference 2, difference 2, difference 2. So all difference are coming 2. So there has to be something similar between the series. So homologous series also has to have something same. What is same? CH2 group. Clear? What is same? CH2 group. So everyone's difference has to have CH2 group difference. Understanding? Everyone's difference has to be CH2 group difference. Let us write. Let us see how it is happening. Alkene series. Alkene. Clear? Who is the first member? Alkane first. Let's take CH4. Following member C2H6. Following member C3H8. Following member C4H10. Okay. Now check the difference. Difference CH2. Difference CH2. See, difference is 2. Difference CH2. So all are having the same differentiation. Another series is being formed. So homologous series is a series. Is a series or a group of organic compounds that is having a similar structure. Structure is similar, not same. Similar, same, difference you already know in maths. Similar structure and similar chemical properties in which successive compounds will differ by CH2 group. Clear? So similar structure, not the same structure, similar structure and similar chemical properties, and successive compounds will differ by CH2 group. Clear? Series you can check, difference you can check. Clear? All this will happen for all the same. Same thing will go for alkene and alkyne also. Okay, who is the first member of alkene series? C2H4, correct. Following member C3H6. Following member C4H8. Following member is C5H10. Correct. Check the difference CH2 group. Check the difference CH2 group. Check the difference CH2 group. So all of them have the same difference CH2 group. Clear? Understood? Now let's check for ethyne also. Alkyne. First member is C2H2, correct? Second member is C3H4. Then is C4H6, and then is C5H8. I think I did not make a mistake. Okay, clear? Check the difference CH2 group. Check the difference CH2 group. Check the difference CH2 group. So you can see all the series, they have a difference of CH2 group. Clear? Understood? Now think logically. If they all are having the difference of CH2 group, so can you add CH2 to this to get this? Definitely you can do that. Definitely you can do that. So if you subtract from here CH2, you will get this. Talking about basic maths now. Okay, basic maths. Suppose series I showed you was 1, 3, 5, 7. So if this difference is 2, so should I add 3 plus 2 will give me 5, or if I subtract from 5 2, you will get 3. So from here also, if the difference is similar, we have already seen the difference is same. So if we can subtract from here the difference, we will get this value, and if we add the difference to this value, we will get the next value. Just like we are doing in maths. Understanding? Nothing different from maths. Same thing is going on over here. In maths also, if the difference is this, you add this to get this, and you subtract this from this to get this. Right? Correct? Similarly, we are subtracting CH2 group from this to get this, adding this to get this. Okay? Understood? Clear? Okay? Now if they are differing by a CH2 group, atomic mass is 14 because C is 12 and H is 2, so 12 plus 2 is 14. So if they are differing by CH2 group, that means they are differing by 14 AMU mass. Clear? So everyone is differing by 14 AMU mass. Understood? Understood? Okay, next thing we are going to do today is alcohol, and then I will be talking about functional groups. I will be doing about alcohol, then I will be talking about functional group, and in the next video, nomenclature. Okay. Alcohol. This word needs to be very much focused on. all, or nol, depends on what will be the name. Clear? Okay. If the name comes like pentanol, then you cannot write pentan again nol, then pentanol. But if it comes decanol, clear? It will become like this. Clear? Depends wherever you will make. Clear? You need to keep in mind this now. When you go to nomenclature, you need to discuss that. Okay? Alcohol. General formula is CnH2n plus 1 OH. So the first member becomes C1H3OH. So we do not write like this. We write CH3OH. It is the first member of the alcohol group. Clear? First member of the alcohol group, that is methanol. Clear? That is why I said it's all words. So it's methan. We need to specify single bond or double bond or triple bond. Single bond is there, so methan. Specify the word methan, then all. Clear? Understood? Methanol. Second member will be ethanol. Clear? Third member propanol. Fourth member butanol. Then pentanol, hexanol, going on like that. Clear? So next member will be C2H. How much? 5OH. Clear? You can see difference is CH2. Difference is CH2. It has to be depending on CH2 difference. Clear? Understood? So the next member is this. Name comes as to be ethanol. Clear? Okay. Understood? Okay. Now we'll be discussing about functional group and next nomenclature. Not in this video, don't worry. Okay. Functional group. Functional group is basically an atom or a group of atoms. It can be one atom or it can be a group of atom or group of atom which will be arranged in a specified manner and it will be responsible for the chemical properties. Clear? It has to be linked in a specific manner only. Vice versa cannot happen. Clear? So it is an atom or a group of atom that is linked in a specific manner and is responsible for the chemical properties. Clear? That is the functional group. What functional group we are going to learn? We are going to learn the functional group. First one, it's halide. It's actually called halogen. When you will do nomenclature, it's halogen. So halide is represented by X. X can be anything. Fluorine, chlorine, bromine, iodine. Either of these you can be X. Clear? We will be presenting halides with X, halogens with X. Whenever a compound is formed, it's haloalkanes. Generally it's haloalkanes. Clear? Okay. Types of organic compounds form this haloalkanes. Halo. H-E-L-L-O? No, it's H-A-L-O alkanes. Okay. Haloalkanes. Clear? What is the general formula? General representation, it's Rx. Clear? We represent Rx. It can be NaI. I'm just giving example. It can be NaF. It can be NaCl. These are all haloalkanes. Clear? Now I am not going to haloalkanes anymore. Okay. Nomenclature. Whenever you will get reactions, like reaction will contain like this, that will be represented by NaX. Clear? But this will not fall under this category. Clear? This will not fall under this category. Okay. I just showed some compounds that has X, that is can be F, can be Cl, can be Br. Clear? But here R indicates a methyl group, not CH3. Alkyl group. Clear? Alkyl group. It can be CH3, it can be CH3 followed by another CH2, that is C2H5 is propyl. Alkyl is basically methyl, alkane is there, subtract one hydrogen from each, that is alkyl radical. Clear? Methane is there, subtract one CH3, first member CH3. Second, propane was there, no, not propane, sorry. Next member whosoever is there, subtract that term. Clear? Hydrogen one subtracted. Clear? The C2H5. C2H6 was the next member, that is ethane, subtracted one, corporate. Next member was C3H8, subtracted one, C3H7, butyl is the next one. Clear? This is the way to write. So CH3, CH2, CH2. Clear? Understood? This will be an alkyl group. So it can be any alkyl group present over here. It can be any alkyl group. Now, if I write CH3Cl, that's methyl chloride that you already got in the addition, there substitution reaction that you have done before also. Right? You have done in the substitution reaction before. There you have got that. This is methyl chloride, not IUPAC name. Chloromethane is IUPAC name. Okay? Clear? So R has to be the alkyl group that will be present. R always represents alkyl group. X always represents the halides. Clear? Understood? Next we are coming to OH, that is alcohol. Whenever you find in the reaction is given as OH, it's alcohol. Okay, it's alcohol. Whenever you see that, it's alcohol. Clear? Represented by OL. I am not writing any formula because we have already dealt with alcohol before. Clear? Next, coming to aldehyde. Spelling ALDEHYDE. Aldehyde. Clear? Aldehyde. Whenever you find RCHO, what you will find? CHO. Whenever you find CHO, it's an aldehyde. Clear? Now, it's not always like directly CHO will be given in the question. No, it might not be given. In that case, there has to be something different that will be done. When CHO is directly not given in the question. Clear? Basic thing is, if CHO is present, it has to be the aldehyde represented by AL. Clear? It's present in the front. Clear? Aldehydes AL has to be mentioned when you are writing the answer. Clear? Now suppose instead of R I write CH3 CHO. What will be the name then? Carbon. Count the carbon. How many? Eth. Then ethanol. Clear? Ethanol or ethanol, whatever you say. It's ethanol. Clear? Next, if I write HCHO. HCHO. It's methanol. Clear? Methanol. And this has got a common name, formaldehyde. Formaldehyde. Okay? Not needed. I am just saying. Okay? Formaldehyde. Clear? Common name of methanol is formaldehyde. Okay? So it's CH3, CHO. That you need to remember. Formula I have written. Clear? So whenever you find this CHO, it's nothing but this. Clear? Now, it's not always that it will be in this format. Like, if I write C double bond O, is this something different? No, same thing. CHO here and R. So you are apparently coming to the same thing. Seeming like something different. Apparently seems like different. But it's the same thing coming. So in the nomenclature you might be given like this. Then you have to think that this is this. Clear? Every time you will be given this only is not the thing. Structure is actually this. Clear? Structure representation is this. This is basically general formula. Clear? RCHO. Okay? Aldehyde represented by AL. Okay? Now if I draw the bond line structure of formaldehyde, formaldehyde will look like HC double bond O, and over here another hydrogen. Clear? Understood? HHO. This is aldehyde because this part is CHO and this part is H. So it's a formaldehyde or methanol. You cannot write formaldehyde in IUPAC name, please. Okay? So it's methanol. Aldehyde complete. Next, coming to the next one, it's carboxylic acid. It's carboxylic acid. Carboxylic acid. Now see, carboxylic acid is COOH. Now it's not always that COOH only has to be there. Might be something else is there in different format, but this apparently comes to this only. Then in that case also you have to think properly. Clear? So COOH will always end with the OIC acid. Will only end with the OIC acid. So it's methanoic acid, ethanoic acid. Clear? Understood? Clear? Actually the structure will look like RC double bond O with OH. Clear? This is also COH. Clear? Okay, COOH. So it's RCOOH. Okay, R bonded with COH. That's oic acid. Clear? Next, second last, ketone. Next, second last, ketone. I will be not discussing much about ketone because that's not there in the syllabus right now. Okay, just know the formula, ketone. Okay, wherever you see ketone, R C bonded with this and double bond, this is ketone. Clear? Wherever you find this structure, this is ketone. I will put it rather like this. R can be equal to R dash, R might not be equal to R dash. Difference is there, asymmetrical, symmetrical, not there in the syllabus. Okay, clear? So to just remember this. Next comes to ketone, you have to end with on. Clear? So if it's propanon, it's ethanon. All this has to end with clear ONE. Okay. Propanon, ethanon, pentanon, whatever it is. Last one, it's ether. Ether is this. Clear? It's ether. Clear? Example only, limited example we will do for now. It's dimethyl ether. Clear? If it is CH3CH3, it's dimethyl ether. Clear? IUPAC name stands as methoxymethane. Okay, nomenclature is currently not there in the syllabus for ether. Generally it does not come also. Generally it does not come like that. Okay, it will be given some limited only. Clear? So here if we put CH3, general formula is this. Okay, and here also if we put CH3, it becomes methyl, dimethyl, 2-methyl, dimethyl, ether, methoxymethane. Clear? So that is all for the functional group that we have to learn in this video. In the next video, we will be discussing about the nomenclature of organic compounds. So do watch the next video positively because that is going to be a very important part of this organic chemistry. Thank you. See you all in the next video.